Hey everyone, thanks for tuning in. Today we're going to be looking at the gradient and basically how it relates to the angle of inclination. Okay, so in this lesson we're going to be looking at how we actually get the formula, what is the angle of inclination, and I'll just be taking you through two examples. Okay, so first off we look at what is the angle of inclination. Okay, so we define the angle of inclination as the angle that the line makes with the positive direction of the x-axis. Okay, this is very important here. It's the positive direction of the x-axis. Okay, so if we look over here at this line, what we have is, this is our angle of inclination in red. Okay, so that's our theta, that's our angle. And recalling the definition, it's the angle the line makes with the positive direction of the x-axis, and that direction is here to the right. Reason being is that the x-axis increases from left to right. So the further right we go, the more positive we go. Hence, towards the right is the positive direction of the x-axis. Okay. So once we understand this, then it should be pretty simple to realize that that ends up being the angle. And if we're looking at this line over here, remember it's the angle that the line makes with the positive direction of the x-axis. So we take the positive direction and we read it counterclockwise until we get to the line. And so it's going to be that angle here. Okay, so how do we actually get the formula? So if we look at a line like this, okay, what we end up having is that we can construct a right angle triangle amongst the line, and what we should realize is that in relation to theta, this vertical height here is the opposite side. Okay, and this horizontal length here is the adjacent side. Alright, and if we just recall the definition of like how we define gradient, which is saying that the gradient is equal to the rise over run. In this case, the rise is going to be this vertical here, and the run is going to be the adjacent. Okay, so by kind of just substituting it into the formula, we've got that m is equal to the opposite side, whatever that length is, over the adjacent side. And hopefully we can recall that opposite over adjacent is the definition of tan theta. So that's how we define the angle of inclination, like that's how we relate the angle of inclination to the gradient. So we define the gradient to be equal to tan of the angle in which the line makes with the positive direction of the x-axis. So once we've got our formula, we can get into some examples. The first example we've got is nice and simple. It asks us to find the gradient of a line with angle of inclination 135 degrees. So recall that the gradient m is equal to tan of theta. So our gradient in this case is tan of 135 degrees, since that's our angle. And that's just it. Like if we just plug that into our calculator, we obtain that it equals -1. So this line is has a gradient of -1. And that's really it for this question. The next question states, find the angle of inclination of line with gradient 1. Okay, and then we'll look at gradient -√3. Now these ones here require, you to apply the formula a bit more. Okay, but it's still relatively simple. So if we look at for part A, the line with gradient 1. Okay, what we got going on is we can say, well, we know m is equal to tan theta. And that then implies that theta is inverse tan of the gradient. Okay, so for part A, we can say that theta is inverse tan of 1, and that gets us 45 degrees. So the angle of inclination that this line makes with the positive direction of the x-axis is 45 degrees. Okay, now for part B, actually I'll do it here. For part B, it takes a little bit more care. Mainly because if we say, well, theta is the inverse tan of the gradient, what we'll obtain is that it's equal to the inverse tan of negative root 3, okay, which will give us negative 60 degrees. Now, usually we're usually used to seeing like a positive angle, okay? So see how this angle here is positive, this angle is positive. This angle over here is negative that we've obtained, this negative 60. Okay, so how can we make sense of this? And what we can realize is that if we recall how we measured trigonometric angles, we measured them from the positive direction of the x-axis counterclockwise. That was if it was a positive angle. But now if it's a negative angle, what this implies is that we have a line which goes down 60 degrees. So it goes 60 degrees in the clockwise direction, sort of like that. Okay. Now obviously this is a straight line which doesn't just stop at 0 but rather continues on. Okay. And what we can hopefully see is that we have a straight line over here. Okay. And typically our angle is being asked for this one. Okay, so the angle we're dealing with is going to be positive, and it's going to be this one. Okay, because it's the angle it makes from the positive direction of the x-axis to the line, reading it normally. Okay, so it's this. And because its angle's on a straight line, you can say it's 180 minus 60. Okay, which hopefully you can already deduce is going to be 120 degrees. Okay. Now, how do we do it here? Well, we just say theta is equal to negative 60 degrees plus 180 degrees, which gives us 120 degrees. Okay, so this is very important to remember only when we have a negative gradient. Okay, this only happens when we have a negative gradient. Okay, for all positive gradients, we're gonna, have a nice, neat equation. But for negative gradients is what they generally tend to assess in exams because it requires that understanding. All you need to do is this extra step. Okay, so you need to add 180 to it for the same reason as what we did here. Okay, so I hope this makes sense. Overall, this isn't very difficult. So yeah, I hope it made sense and you guys learned something today. And I'll leave you with that. Enjoy.